Video contains the solutions for the first two of the free response practice questions for sections 7.1 and 7.2. First one, 1A, we're supposed to find the area of this region, and to do that we need to know from where to where. So the first thing I'm going to do is go ahead and graph them. So I'll get the square root of x and e to the negative 3x. And from 0 to 1, I think my window is actually pretty reasonable. Oh, there they are. They're cut off right here in our graph. And second, calculate the intersect. You know, with this first curve, if you have more than two curves in there, you can still work with that. So I just have to hit enter a few times. It should show me my intersection point at 0.2387. I'm going to keep 4 decimal places. So intersection point is at 0.2387. I'm just going to call that point P from now on, so I don't have to keep writing it down. So let's see. Part A, the area would be the integral from 0.2387 to 1. The square root function is on the top, minus e to the negative 3x. Be very careful to write that out. I could have written a p there, actually, and because you will get points for just writing that out. And back to my home screen. So math 9, fn int, the square root of x minus e to the negative 3x, comma, x, comma, 0.2387, comma, 1. That's 0.443 to 3 decimal places. Alright, now, how about the volume when we rotate this around the line y equals 1? So we're rotating around this line like this. Well, when I rotate this way, notice that the two functions switch places. This becomes like the outer radius, and this one is the inner radius. So that's going to change which one comes first. So I have pi times the integral from 0.2387 to 1. This time the e to the negative 3x comes first, minus the square root of x squared dx. Just in case I forget the pi, I'm going to go ahead and put the pi on. So that's pi times math 9 fn int. That squared, you don't have to do this, but I'm just going to, for less of a messy entry here, e to the negative 3x squared is e to the negative 6x minus the square root of x squared is just x, comma, x, comma, 0.2387, comma, 1. Uh-oh. Let's see, did I forget to switch the order of them? What did I do? That can't be right because it can't have a negative area, right? So let's see. No, that's the right. It should come first. Oh, I forgot that I'm rotating around y equals 1, which means inside each one of these there should be a minus 1. Let me go back and fix that. Actually, let's just type it in over again. Alright, so math 9. Well, I'm entering that. You might think about why it came out to be negative there. So if I hadn't rotated around y equals 1, then they wouldn't have been, we wouldn't have to switch the order. So I think that's why we got a negative. So let's see. I can't do my little squaring trick now, can I? So e to the negative 3x minus 1 squared minus the square square root of x minus 1 squared excuse me, comma x, comma 0.2387, comma 1, and I did not multiply that by pi yet, so I'm going to go ahead and multiply that by pi times my answer, 1.424. If you look at the rubric, scoring rubric, they have these things the other way around from what we did, but when you square that, it doesn't matter, because whether this is positive or negative, that's the only difference when you flip those, and we're squaring it, so it doesn't make any difference. It would still be fine, and you'll get full credit for that. All right, part C. The region is the base of a solid, so now all of my little cross sections here are the base of a rectangle. Now each one of those is just the square root of x minus that, so e to the negative 3x, and then this is 5 times as tall. So the area is the integral from 0.2387 to 1 of 5 times the square root of x minus e to the negative 3x squared dx. Let's see if we can do that. So 5, of course the 5 could be inside or outside, it doesn't matter. So math 9, we're going to do 5 times the quantity square root of x minus e to the negative 3x, close the whole thing, square it, it should be right, comma x, comma 0.2387, comma 1. That should give me my last part, 1.554. Be real careful with calculator entry, but if you look at the rubric for all 3 of those parts, the answer is only worth 1. The integrand means this part, right? So the limits, correct limits in an integral, right? That means the right intersection points. The integrand is all this junk in here, and then the answer. So even if you made calculator errors, you're still going to get 6 points out of the 9 on that. So be careful with your setups. All right, next. Here we have 2 functions. First part of this one, we want to show that L, this line, is tangent to this function at 3. Well, there's more than one way to do that, but I think, to my mind, the easiest way is just find the equation of the tangent line at 3 and show that it is in fact that. So, to find the equation of a tangent line, I need a point, and I need slope. So my point would be 3, comma, let's see, 4 times 3 squared, that's 4 times 9, 36 minus 27. 36 minus 27 is 9, right? Last time I checked. And the slope, well, the derivative of that would be 8x minus 3x squared. So the derivative at 3 would be 24 minus 27, or negative 3. So that's my slope. So in point slope form, that's y minus 9 is equal to negative 3 times x minus 3. And simplifying that, minus 3x plus 9, that's y equals negative 3x plus 18. So, mission accomplished. All right, part B, find the area of S. Well, S is kind of a funny area. It's not the area between 2 curves, really. It's really the area of this triangle minus the area of this region. Under R, from 3 to, I don't know where that is. I'm going to have to find that, right? Actually, it's just a 0 of this, isn't it? I guess we could find that, what are the zeros of this? 4, right? So it's 4. You could graph it, of course. Your calculator is active here. But if you factor out the x squared, it turns out that that 0 is just 4. So this is what I need. I need area of the triangle minus the area from 3 to 4 under the f of x function. So let's see, the triangle is, this intersects here at, let's see, that would be where the y is equal to 0, so that's at 6. Right, again, you can use your calculator for help here if you want. So that's a 3 by, when we plugged 3 into the function, this was 9 high, right? So that's a 3 by 9 triangle. So the area of the triangle is 1/2 base times height, right? Again, I knew the 9 because I found that in part A. Minus the integral from 3 to 4 of 4x squared minus x cubed dx. You could do that by hand, but you would be crazy to do it on the real test because this is all calculator active. So let's do it with our calculator. So I got 1/2 times 3 times 9 minus math 9. The integral, we've got 4x squared minus x cubed comma x comma 3 comma 4. Right. And cross our fingers, that's 7.917. Oops, 917. But that looks like a repeating decimal, so I'm going to go ahead and enter that, and that's 95 over 12. So either way. And let's check that. Yep, they have 7.916 or 7.917. So good. Part C, find the volume of the solid when the region R, that's this region, is rotated around the x-axis. Well, that should be easy, right? We found this intersection here. It's 4. So that should just be pi times the integral from 0 to 4. Oops, sorry, off screen there. Pi times the area from 0 to 4. And it's not hollow, it's just the 4x squared minus x cubed squared dx, pi r squared dx, from 0 to 4, right? Let's see if we can get an answer for that. Again, you could do that by hand, but you'd be crazy because we've got our calculators active here. So let's see, I got pi times math 9 of parentheses 4x squared minus x cubed all squared comma x comma 0 comma 4, and that is 490.208. And that checks out with our key. So there's your first two. So you can see, like, when you see one of these, those first two took about 7 minutes apiece. So on the real AP test, this is a great opportunity to get some points, check your work, and still have plenty of time to do other stuff.